Good morning, students. Let us proceed to the third part of the second chapter. Is matter around us pure? We already got our answer to the question that was raised through our chapter name. Is matter around us pure? Maximum matter around us is in the form of mixtures, impure substances. But there are some substances that are in pure form, pure substances. Now let us recall what we have studied in our previous classes. In our first part, we have classified matter based on purity. There is a broad classification of matter based on purity. Two categories, pure substances and mixtures. Hence, we have classified matter into two main categories, pure substances and mixtures based on purity. What are pure substances? Pure substances are the substances that are made up of only single kind of particles. Whereas mixtures, impure substances, are made up of two or more than two kinds of particles. And in our second class, in the second part, we further classified pure substances based on composition. There are two categories, elements and compounds. Hence, we have classified pure substances into two categories, elements and compounds based on composition. Now, elements. Elements are the substances that are made up of only one kind of atoms, whereas compounds are formed from chemical combination of elements, two or more elements it may be, chemical combination of two or more elements in a fixed ratio. Hence, elements are made up of only one kind of atoms, whereas compounds are made up of two or more elements that are combined chemically in a fixed ratio. There are two main properties of compounds. Since compounds are made up of by chemical reaction of elements, the property of compound is totally different from its constituent. Since it is a chemical change forming of compounds from elements is a chemical change, so the property of compounds is totally different from its constituents, that are elements. Hence, we can say property of a compound is totally different from its constituent elements. One more property is that we can break a compound into its constituent elements by chemical or electrochemical methods. So this is all we have read till now. Let us proceed now. This is the classification of matter. In our first class, we have broadly classified matter into two categories based on purity: pure substances and impure substances. Impure substances also can be called as mixtures. In our second class, we have classified pure substances based on composition. There are two main categories under that: elements and compounds. Now in this class, we will further classify elements based on various criteria. We are going to classify elements based on physical state, based on number of atoms present, and based on properties. Now, elements can be classified based on physical state, whether it is solid element, liquid element, or gaseous element. On the basis of number of atoms present, we can classify elements as monoatomic, diatomic, or polyatomic. and based on properties, we can classify elements into metals, non-metals, and metalloids. Now we will study each criteria in details. First, we will classify elements based on physical state. We already read what are the three physical states: solid, liquid, and gas. We can classify elements based on this physical state. It may be solid elements, liquid elements, or gaseous elements. We will now go through few examples. Solid elements. It may be iron, gold, silver, copper, carbon, etc. These are all solid elements. They are present in the solid form or the solid state at room temperature. There are mainly two liquid elements, mercury and bromine. They are in liquid state at room temperature. There are many gaseous elements: oxygen, hydrogen, nitrogen, helium, chlorine, fluorine, neon, argon, krypton, xenon, radon. These are all gaseous elements that are present in the gaseous form at room temperature. Now we can also classify elements based on number of atoms present. It may be monoatomic, diatomic, or polyatomic. Monoatomic. Mono means one or single. So there will be only one atom present in that element. Diatomic. Di means two. So there will be two atoms present in that element. Polyatomic. Poly means more than two. So there will be more than two atoms present in that element. Now let us go through few examples. Monoatomic elements: helium, neon, argon, krypton, xenon, radon. They all exist in monoatomic form in the nature. Diatomic: oxygen O2, nitrogen N2, hydrogen H2, chlorine Cl2, bromine Br2, iodine I2, fluorine F2. They all exist as diatomic form. Two atoms present in a element. They all exist as a diatomic form in nature. Now polyatomic: phosphorus P4, sulfur S8. So these are the examples of polyatomic. Means more than two atoms are present. In phosphorus, four atoms combine to form P4. 8 atoms of sulfur forming S8. So these are polyatomic elements. Hence, we have classified elements based on number of atoms present. Now, the third criteria based on which we are going to classify elements. We already classified elements based on number of atoms present, monoatomic, diatomic, and polyatomic. We have also classified elements based on physical state: solid elements, liquid elements, or gaseous elements. Now we will classify elements based on properties. May it be metals, non-metals, or metalloids. Now we will study each one: metals, non-metals, and metalloids in detail. Now we will learn few properties and examples of metals. First property: metals are generally hard at room temperature, but sodium and potassium are soft metals at room temperature. Next property. Second property: metals are generally solid at room temperature, but mercury is the only liquid metal at room temperature. Third property, metals are lustrous, means they are having shiny appearance. Fourth property, metals are sonorous, means they produce a deep and ringing sound when hit. Now fifth property, metals are malleable, means they can be beaten into sheets. We can make sheets out of the metals. Hence, malleability is the property of metals. Next, metals are ductile, means metal can be drawn into thin wires. So, ductility is again a property of metals. Next property, metals are good conductor of heat and electricity. That means metals allow heat and electricity to pass through them. Next property, metals usually have high melting point and boiling point. Now, here are few examples of metals: gold, silver, copper, iron, etc. Now, let us match properties we have learned for metals with any one of these examples. Take iron. Iron is hard at room temperature. Iron is solid at room temperature. Iron has luster. Iron makes sound when heat. Iron is malleable, can be beaten into sheets, thin sheets. Iron is a good conductor of heat and electricity. Iron is having high melting point and boiling point. You can take example of copper also. Copper show ductility. Copper wires. You have already seen copper wires. Hence, copper can be drawn into wires. So these all are the properties of metals. Now moving on to the next about non-metals. Non Non-metals are generally soft. Solid non-metals are generally soft except an allotrope of carbon, that is diamond. Diamond is made up of carbon atoms only, but diamond is very hard, whereas other solid non-metals are soft. Next property, non-metals exist in all three states: solid state, liquid state, gaseous state. So non-metals existing in all the three states. Solid non-metals example, carbon, phosphorus. There is only one liquid non-metal at room temperature, that is bromine. Gaseous non-metals, oxygen, nitrogen, hydrogen, etc. Next property, non-metals are generally non-lustrous. They do not have any shiny appearance. Moving on to the next, non-metals are non-sonorous. They do not produce sound like metals. Non-metals do not show malleability. Non-metals are not malleable. That means we cannot make thin sheets out of any non-metal. Also, non-metals do not show ductility. Non-metals are not ductile. That means we cannot draw thin wires out of non-metals. Next property, non-metals are generally bad conductor of heat and electricity, means they do not allow heat and electricity to pass through them. But there is an exception, graphite. Graphite is a good conductor of heat and electricity, although it is a non-metal. Next, the melting and boiling point are generally low in case of non-metals. Now there are few examples of non-metals. fluorine, chlorine, helium, neon, hydrogen, iodine, etc. Now, moving on to the next, that is metalloids. Metalloids, they have intermediate properties, those between metals and non-metals. Means metalloids are in the boundary of metals and non-metals. Hence, they are called semi-metals also because they are having half property of metals. There are few examples of metalloids such as boron, silicon, germanium, arsenic, antimony, etc. So we have classified elements based on properties into three main categories: metals, non-metals and metalloids. This is the periodic table. Here you can get clear distinction between metals, metalloids and non-metals. On the left side you can see most of them are metals. On the right side you can see most of them are non-metals. And in the boundary line of metals and non-metals there are metalloids. It is shown by orange boxes. So metalloids are the intermediate between metals and non-metals. They are having intermediate properties of metals and non-metals. Hence, in this class we have classified elements based on three criteria: based on physical state, based on number of atoms present and based on properties. Hence, we have totally classified pure substances. Next day, we are going to classify impure substances into two main categories: homogeneous mixture and heterogeneous mixture. Now about class notes. You have already made the flowchart of classification. You have classified their matter into two parts: pure substances and impure substances. You have classified pure substances further into elements and compounds. Now you have to extend that flowchart. You have to classify elements further into three categories: based on physical state, based on number of atoms present and based on properties. So you have to make that flowchart. Next, second point, you have to give the topic classification of elements based on physical state. Under that topic you have to write solid elements, liquid elements and gaseous elements, and you have to just give the examples there. Third point, classification of elements based on number of atoms present. You have to make the column of monoatomic elements, diatomic elements and polyatomic elements, and only give the examples. No need to write definition because this thing we are going to study in detail in next chapters. Now fourth point, classification of elements based on properties. You have to give the subtopics: metals, non-metals and metalloids. Under each subtopic you have to write properties and examples. Now we have totally classified pure substances. Now next day, next part 4, we are going to classify impure substances into two main categories: homogeneous mixture and heterogeneous mixture. Bye bye till then. Meet you in the next class.